Take note, concept summary. Transformations of f of x. Well, vertical translations. A translation up k units, if k is greater than 0, can be represented y equals f of x plus k. A translation down k units, assuming again that k is greater than 0, can be represented as y equals f of x minus k. Horizontal translations, to the right. A translation to the right h units, assuming h is greater than 0, can be represented y equals f of the inputs x minus h. A translation left h units, again with h greater than 0, can be represented y equals f of the inputs x plus h. Bottom left, vertical stretches and compressions. First, a vertical stretch, assuming a is greater than 1, can be represented y equals a times f of x. A vertical compression, now assuming a is greater than 0 and less than 1, can be represented y equals a times f of x. Finally, reflections at the bottom right. In the x-axis, y equals negative f of x. In the y-axis, y equals f of the inputs negative x. Problem 5, combining transformations. Part A, the graph of g of x is the graph of f of x equals 4x compressed vertically by a factor 1/2 and then reflected in the y-axis. What is a function rule for g of x? Well, first we'll compress f of x. So 1/2 times 4x, that's 2x. Then we'll reflect the new function in the y-axis. So our input, rather than being x, will now become negative x. So 2 times negative x, and that simplifies to negative 2x. So our function rule, g of x, equals negative 2x. Part B, let f of x equals 2x squared and g of x equals 6x squared minus 1. What transformations change the graph of f of x to the graph of g of x? Well, first we'll rewrite g of x. G of x is 6x squared minus 1. Keeping in mind that f of x equals 2x squared, we'll identify 2x squared if we factor 3 out of the first term. So we can rewrite 6x squared as 3 times 2x squared. Then f of x appears within the expression equal to our function. So rewriting 6x squared minus 1 as 3 times 2x squared minus 1, that's the same as 3 times f of x minus 1. So we can state the graph of g of x is the graph of f of x stretched vertically by a factor of 3 and then translated down 1 unit. Your turn, part A. The graph of g of x is the graph of f of x equals x stretched vertically by a factor of 2 and then translated down 3 units. What is the function rule for g of x? Part B, what transformations change the graph of f of x equals x squared to the graph of g of x equals x plus 4 squared minus 2?